Welcome, calculus students. We are going to do our basics about concavity. So what is concavity? Concavity is basically when your graph is turning. So if you think of a function like y equals x squared, it is always up or bending upwards. So this is an example of a function that is always concave up. Versus something like y equals x cubed, this function actually has a portion which is turning down and a portion which is bending up. So this portion here that is turning downward is called concave down. And this portion which is turning upward is concave up. So basically, anytime you have a curve that has some bend to it, it's either going to bend down or bend up, and we're interested in figuring out where does it change. So where it changes is called an inflection point. Now, there's actually one other place that a function could also change concavity, and that has to do with a rational function. So if you had something like y equals 1 over x, and we know that that function looks like this and this. It is concave down on this section. And it is concave up. And by the way, I'm just going to teach you right now. Concave up is CU, concave down is CD. I mean, come on, let's stop writing it. Anyway, where this one is changing concavity is not at a point, right? It's changing concavity at the vertical asymptote. Okay, so looking at our three examples, parabola, always concave up, a cubic, where it's changing some at a specific point somewhere in the middle, or a rational function where it's changing at a vertical asymptote. All right, so how can we find out where it's changing if it's changing? That is called an inflection point or a vertical asymptote. But basically, how we figure out where it's changing concavity and what kind of concavity we have what we basically have is that we're going to do the following. Okay, so what we're going to do is, number one, we're going to find the second derivative. So the first derivative finds our critical numbers that are maxes or mins. Our second derivative finds inflection points. Okay, so what we're going to do is set it equal to 0 or where it's undefined. And those are going to be where hopefully it's changing concavity. Now, to test what kind of concavity you have, we're going to make a number line. We're going to plot our possible inflection points and test into the second derivative. So it's very much like we saw in class with the increasing and decreasing functions where you use the first derivative, but for concavity, you use the second. So let's go ahead and try one example. Let's go for it. Okay, so the example that I'm going to do is going to be the function x cubed minus 3x squared. Okay, so this function, if I find the first derivative, it is 3x squared minus 6x. If I find the second derivative, it is 6x minus 6. So we're going to set that equal to 0. We're going to solve, and I believe we're going to get that x is 1. All right, so this is my possible inflection point. All right, so what I'm going to do now, I'm going to come over here. I'm going to plot only that spot, which is 1, and I'm going to choose any point that lives to the left of 1, so like 0, and any point that lives to the right of 1, like 2, and plug that into the second derivative. And what I'm looking for is positives or negatives. Okay, so if I plug in 0 into the second derivative, I get 0 minus 6 is negative. Now, when you're negative, you're sad. And if you're sad, you're concave down. So negative refers to concave down. Okay, when I plug in 2, I get 6 times 2 is 12. 12 minus 6 is 6. It's positive. When you're positive, you're happy. And when I'm happy, I smile and I'm concave up. So what we have here is the following. We are concave down from negative infinity to 1. We are concave up from 1 to infinity. And my inflection point is when x is 1. Uh-oh, what's the y value? All right, well, when x is 1, if I plug 1 in up here, one more. 1 cubed minus 3 times 1 is 1 minus 3 is negative 2. So my inflection point is actually not just 1, it's the point 1 comma negative 2. All right, so I'm going to label that IP for inflection point. Hope that helps.